Hello, this chapter cover wireless WAN network for worldwide connection. After this chapter, you will learn first, recognize specific wireless WAN application. Second, understand wireless WAN component and standard. And third, realize the wireless WAN system. Wireless WAN certified need for networking over vast distance, such as countries and continents. In most cases, wireless WAN offer connection while away from the office, home, and the indoor public wireless LAN. Wireless WAN do provide coverage inside buildings, but performance in this area is often much less than when operating outside. The advantage of wireless WAN is wide coverage and economies of scale that result in low price for subscribers. The disadvantage is that the limited availability of frequency spectrum result in low performance and limited security. However, one more practical than wireless LAN to deploy in large areas. For the wireless WAN component, wireless WAN certify both mobile and stationary applications. Therefore, vary depending on the technology and configuration of the wireless WAN. A satellite-based wireless WAN has different components than a cellular-based system. For wireless WAN user device, user of wireless WAN operates a small and affordable device. This is because access to the network is available over much wider area and the user must carry their device with them. Figures show illustrate the type of user device most common to wireless WAN. The use of wireless WAN to network stationary PC is not common. However, some applications do exist. The need to set up portable point of sale register at the remote area such as a makeshift concern site. For the radio and IC, to interface a laptop or PDA to a wireless WAN, you need to purchase an applicable wireless WAN radio and IC. This figure shows a radio and IC available for wireless WAN. For the base station for wireless WAN typically appear outdoor. In fact, the familiar cell towers shown in figure are seen scattered around cities and country areas. Similar to wireless LAN, this base station rely on wire to connect to a distribution system that provide switching and an interface to the internet. In most cases, the tower reside outdoor to provide maximum coverage. Another form of wireless WAN base station is satellite in orbit, which is actually a repeater in the sky. On the ground, a user aims to dish antenna at the satellite, and the satellite receives the signal and transmits the signal back to an Earth station. The figure shows the satellite have a signal transponder that sends and receives RF signal and solar cell that provide electricity. For the antenna, wireless WAN base station and user device use a variety of antenna depending on the type of wireless LAN. For cellular system, the antenna on the user device is generally omnidirectional. Cell towers generally have a multiple directional antenna. However, that cover was distant. A satellite user has a dish antenna with characteristics as shown in the figure. For the wireless WAN system, most wireless WAN are cellular based, but some make use of space. Take a close look at both of these. In this figure, a cellular system consists of cell tower, concentrator, voice switches, and data gateway. The cell tower receives signal from user device and transmit information back to the user. The voice switch connects the user device to another wireless or wired user down the telephone distribution system. The component that make the system a wireless one is the data gateway. In this case, the gateway is able to interface with data protocol in a way that makes it possible for users to surf the internet, send and receive email, and utilize corporate applications. For the space-based wireless one, in addition to the land-based cellular system, the use of space-based system provide a means for networking users over wide area. For the satellite, the user the use of satellite for broadcasting, television, and other communication has been around for the several decades. Not until recent, however, did satellite system provide user with connection to the internet. The figure show data rate are applicable with up to 1.5 Mbps download. Some satellite systems support two-way exchange of data, allowing a user to send data up to the satellite. For the example, a user mobile device can transmit a web page request up to the satellite, and the satellite transmit it down to the appropriate Earth station. The Earth station then send the web page down the satellite and back down to the user. Other satellite systems, however, only support a downlink. A user device must request the web page down another network, such as a telephone link, and the satellite broadcasts the page to the user. The band of frequencies between 150 MHz and 20 GHz is the most suitable for an Earth space radio link. It is not practical to establish link to an Earth terminal located in a climatic region of heavy rainfall at frequencies higher than 20 GHz if consistent availability is expected. For all operating bands, the lowest frequency spectrum is used for the downlink because it has the most severe power constraint. Lower frequencies are less sensitive to free space attenuation when compared to the higher uplink frequency. Losses are easy to overcome in the uplink with the higher transmit power available at the Earth station. For the wireless WAN technology, wireless WAN make use for technology that focus on modulation of voice and data. Wireless WAN exclusively use RF signal designed to accommodate many users. Each user has a dedicated channel, and this is different from wireless LAN. This significantly reduces interface between wireless WAN user device and base station. For the frequency division multiply access FDMA divide a wide frequency band into smaller subbands, where each user transmits voice and data over their assigned subband. All users transmit their signals simultaneously, as shown in figure. Illustrate this concept, traditional 1G cellular system use FDMA for sending data. For the time division multiply access, TDMA keep users separate by allowing only one user to transmit at any given time. Each user has an assigned time slot for transmission. Some of the older communication operators utilize TDMA to offer voice and data connection over wireless WAN. The figure shows TDMA make user transmit only during their assigned time slot. For code division multiply access is similar to FDMA. CDMA allows simultaneous transmission. However, is that CDMA user can occupy the entire frequency band at the same time. The user not do experience any interface. The figure shows CDMA assign a code to each user, which makes it possible for user to transmit simultaneously without interface. For the SDMA accommodate multiple users by focusing a beam for each user. This is common in satellite system. Some SDMA systems are adaptive, where the radio beam follow movement of their user. Other systems require the user device to reassociate with the next beam as user move. For the summary in this chapter, wireless WAN includes cellular tower, parabolic antenna, satellite, and telecommunication infrastructure. Most wireless WAN applications make use of outdoor connection, but some indoor facilities such as airport and convention center deploy wireless WAN when large number of subscribers are present. Wireless WAN infrastructure is expensive compared to other type of wireless network, but wireless WAN are the most feasible for covering countries and continents. Cellular and satellite systems are the most common form of wireless WAN capable of providing moderate performance. That's all for this chapter, and thank you.